Good evening. My name is John Kupini, and my preliminary presentation is on cloud computing infrastructure as a service. My supervisor is Associate Professor Ji Zhang, and I am doing Master of Computing. The motivation of my research is cloud computing is becoming a computing technology of the future. Lots of our business start to run their IT systems on cloud platform. The cloud platform offers centralized pool of configurable computing resources and computing outsourcing mechanism, which enables different computing service to different uh, people. However, the main issue we faced with cloud computing is security and privacy. Also, the new characteristics of cloud computing pose new security challenges. So the aim of the research is to address improved security solution for cloud computing in general and cloud computing infrastructure as a service, to address issues with new cloud computing characteristics such as multi-tenacity and elasticity. Also to adequately cover the 6 security issues in cloud computing infrastructure as a service that we have covered in our literature review. To review cloud computing infrastructure as a security solutions covered in the literature and industry as well, and also cover delegation of cloud security level, delegation of cloud security, and level of control and management. The scope of this project includes security responsibility for cloud user in Nectar Cloud. We will use Nectar Cloud to implement cloud computing infrastructure as a service. The vulnerability test in shared security model in the user domain, which include the vulnerabilities, threats, compliance, and other security issues. We'll also do a simulation with Cloud SIEM. I will use a Cloud SIEM with Eclipse in a Java-based environment to simulate cloud data security and the cloud key exchanges. The project scope will not cover cloud providers' area of security responsibility in Nectar Cloud, as we don't have the capability or have access to the Nectar Cloud provider, and also shared security implementation in infrastructure as a service. So the scope of the project will not cover part of the cloud provider aspect. Right, background is cloud computing provides virtualized hardware computing resources via the internet on a need basis. Hardware resources such as servers, processors, storage, memory, network services, and other resources can be provided as a utility service to the users. Those services are used on a simple model as pay-as-you-go model. So the cloud users are going to use those hardware resources as a pay-as-you-go model. Depending on the amount of resources that they use, they're going to pay according to those the resources. This is a new way of offering cloud computing services, which is very important today. Background literature. There were many research done on cloud computing generally, and specifically on cloud computing infrastructure as a service. There were notable researches done, and researchers, literature, came up with a certain um, cloud security infrastructure as a service security model. So the literature discusses cloud computing issues and security solutions, the various security models proposed, and also vulnerabilities were classified to the known threats and attacks. However, generally, the cloud computing infrastructure as a service security threats are similar to cloud computing threats. Okay, this includes cloud computing software as a service and platform as a services. As cloud computing infrastructure as a service is the highest where highest security responsibility or management responsibility a cloud provider can leverage to the cloud users. Therefore, generally it covers a security threats both in the platform as a service and software as a service delivery model. Aurora et al. 2012 did a research on a cloud computing infrastructure as a service security model and proposed a cubicle security solutions. Furthermore, Daiwon et al. 2010 also proposed their security model called the cubicle model. Moreover, Lawal et al. 2013 proposed a cubicle security model for IaaS or infrastructure as a service to guide security assessments and management in the cloud service, cloud computing infrastructure as a service layer. Other research also provide similar solutions in the cloud, the computing in general, in the literature. So this is the cubicle security model, or SMI, which stands for Security Model for Infrastructure as a Service. And it is believed that cubicle security model is mostly recommended in the literature, which is a model that is basically suit the cloud computing infrastructure as a service security solution. It consists of three sides. The front consists of infrastructure as a service components, which includes service level agreements, utility computing, cloud software, platform virtualization, network and internet connection, and computer hardware. The side consists of security models, including configuration policy and management policy and monitoring and auditing. And the depth consists of a restriction level, the restriction or policy restriction level. So this is the cubicle model, which encapsulate whole of the cloud computing infrastructure as a service security threats into three sides. However, this presentation focus on said security responsibility threat and issues, as it deals as the security or cloud computing infrastructure as a security model is based on shared security responsibility model. So based on the shared security responsibility model, it has identified the six categories of security threats and issues. Those include compliance and legal issues, application issues, virtualization issues, data storage, network security, and access control issues. These security threats and issues are directly related to the components of the infrastructure as a service model. So the shared security responsibility solution is based on sharing the security and management responsibility of the computing infrastructure between the cloud user and the cloud provider. So the customer and the provider equally share the burden of the security responsibility and also management of the services within different. So this include security and management of the guest operating system, updates and security patches, configuring firewalls and protecting data and applications. So the cloud computing infrastructure as a service, a cloud provider leverage a lot of security responsibility and control and management to the cloud users. So this is the shared responsibility solution or model. This provides just the abstract view of the shared security model in the cloud computing infrastructure as a service. So to the left, we have left column indicated the infrastructure as a service security issues and threats. This basically relates to the component of the infrastructure as a service. So we have compliance and legal application or software issues, virtualization issues, data storage issues, network security issues, and access control issues. And then we have the cloud customer responsibility solution and cloud provider responsibility solution, which both the customer and provider have the responsibility of ensuring and securing the security threats and issues covered in the infrastructure as a service model there. So this basically shows the abstract view of the security solutions that needs to be considered by both the cloud customers and the cloud provider. Right, the methodologies used in this research are the Cloud Sim, which is one of the simulation software, which we will use to simulate the infrastructure as a service cloud platform. Excuse me. Nectar Cloud Platform. We are going to use Nectar Cloud Platform to implement the infrastructure as a service cloud computing platform there. And Qualys Guard vulnerability check on Nectar Cloud. We are going to use the tool Qualys Guard to check the vulnerability of the security implementation in the Nectar Cloud, and also look at the literature review as well. So Cloud Sim, which providing modeling and simulation of infrastructure as a service cloud and cloud data centers, infrastructure as a service of cloud of data security with encryption and dynamic key exchange in cloud. We will implement the simulation of this data encryption and dynamic key exchange in the Cloud Sim by using Eclipse in Java. Nectar Cloud Platform. This is basically at the user level. A Nectar Cloud Platform will be used to implement shared security solution at the user's end in the IaaS cloud. Also provide the cloud infrastructure and software. Also, the users will have to implement cloud computer network with at least 2 servers running Microsoft and Linux. And the network will also deploy at least more than 5 clients running Linux, Windows, and other OS. The cloud security designs will be able to implement the security solutions discussed in the set security designs. So Qualys Guard in Nectar Cloud will a web-based vulnerability scanner that will be able to scan the vulnerability in the Nectar Cloud that we will propose or we will implement. This provides vulnerability assessment and cloud security assessments. Also provide file integrity monitoring, secure configuration assessment, and also other security compliance assessments. So we will basically use Qualys Guard in the Nectar Cloud to ensure to find out the vulnerabilities of the respective security issues. So the type of scans include vulnerability management scans, map scans, policy compliance scans, and web application scans that will be done by Qualys Guard in the Nectar Cloud as we implement the infrastructure as a service in the Nectar Cloud computing platform. The outcome that is expected of that Nectar Cloud with Coast Guard includes vulnerability and potential vulnerabilities, the report of vulnerability and potential vulnerabilities, threats and potential threats, the impacts, policy compliance assessment, exploitability, and associated malware and other results. A security responsibility matrix will be used to measure and analyze the effectiveness of the security solutions implemented in the shared security solution in the above systems. And I hope that the model used in the investigation would be accurate predictor of the physical reality. Thank you.